Hello class, this is a video tutorial on scientific notation. In some places you may see it as standard notation. So first off, scientific notation, I've abbreviated as Sci notation. Sci notation is used when working with either very large or very small units of measurement. So I wrote two examples here. From the sun to Mars, it's about 229 million kilometers. So when you're looking at this value, we may want to represent it in an easier way, as well as this, the diameter of a hydrogen, diameter of hydrogen is 0. Let me count here. 0.00000000254 meters. So it is just absolutely tiny. Okay, so in scientific notation is written as a number between 1 and 10 multiplied by a power of 10. So here's an example. The first three, A, B, and C, are examples of this. So the first number, 6.7, is a number between 1 and 10, and it's being multiplied by some power of 10. Another example, 3.65 is between 1 and 10, and it's being multiplied by some power of 10. One last time, 2.96, so that's a number between 1 and 10, and it's being multiplied by a power of 10. It's 10 to the power of -7. So these are three examples. D, E, and F are three examples of numbers that are not in scientific notation. The reason for this is that the first number is not between 1 and 10. It has to be 1 and 10. This one, the first number is between 1 and 10. However, its multiplier is not a power of 10. For this to be a scientific notation, it have to be written properly as, it must be written properly in this form. And lastly, this one is clearly not scientific notation, and it is not a number between 1 and 10, and it is not being multiplied by some power of 10. So the main important bit that we need to know is some number between 1 and 10. So it's some number, A, times 10 to the power of B. If we take a look, all of these three look something like this. A, the number in the front, times 10 to the power of B. Okay, so let's now take a look at how to do scientific notation and how to convert in scientific notation. Let's begin first with large numbers. How we do this very simply is just count how many zeros or how many numbers we have behind the leading number. So 3. So from the 3, how many zeros or how many decimal places do we have from here? So 3, 1, 2, 3, 4, 5, 6. So we're going to take this number 3. So this is going to equal 3 times, it's always going to be 10. And how many numbers we counted is the number that goes above the 6. So once again, here we go. This number here is going to be 4 times 10, and we need a number here at the top. And how many it is we just place a little dot here, and we count how many numbers are behind it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10 to the power of 10. Same goes for the number 500. This is going to be 5 times 10. So the number behind, so we put a little dot behind the 5. And we count how many numbers are behind it. So 1, 2, put the number 2. even if it's a number like this, we always take the leading number, so number 4. So this is going to be 4 point, and we take every digit that is not a 0 here. So 4.8. We still count how many numbers are behind the leading number. So we're going to, 4.8 times 10, and then we count 1, 2, 3. 3. Same goes for this one. It's going to be 2.84 because we need the leading number. We're going to put a number here, 2 points. So 2.84 times, we count how many numbers are behind that point. 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the power of 8. And lastly, here we are. This time there's more decimal places. Once again, we place a little dot behind here. So this becomes 2.18 times 10 to the power of, so from this dot we count 1, 2, 3, 4. So it becomes 4. We're now going to take a look into how to do this same method with smaller values. So for this one, it gets a little bit trickier. We're going to first take the first digit that's not 0 from the decimal. So by this we mean it's going to be 4. 4 is going to be our number, times, it's always going to be 10. But since this decimal place is going to be moved here, we count how many spaces in between it takes to get there. So we count how many leaps. It's going to be 1, 2, 3. So it's 4 times 10 to the power of 3. Same goes for this one. Same thing. It's going to be 9. Oops, sorry, not 3. Negative 3. It's going to be 9 times 10. We put a little dot here and we count how many spaces in between it takes to get back to here. So it's going to be 1, 2, 3, 4, 5, 6. So it's going to be 9 times 10 to the power of negative 6. Let's keep moving here. Even if there's numbers behind it, we're still going to take the first number we see. So we're going to place a dot there. This is going to be 7.1 times 10. We count once again. 1, 2, 3, 4. 10 to the power of negative 4. Let's keep moving along here. The first number that we see is the 5, so we're going to put a decimal here. So this is going to become 5.071 times 10. And from that first dot that we put, how many spaces, how many leaps does it take to get back to here? So we're going to put 1, 2. So 10 to the power of negative 2. Once again, same thing. The first number that we see is the 3. So it's going to become 3.402. So all these numbers behind it times 10. And once again, how many spaces? 1, 2, 3, 4. 10 to the power of negative 4. And last one, here we go. Once again, we place a dot behind the first digit that we see, which is 4. It's going to become 4.9 times 10. And we count how many spaces it'll take to get back to here. So it's going to be 1, 2, 3, 4, 5, 6, 7, and 8. 10 to the power of negative 8. I hope that gave you an insight into how to write in scientific notation. Best of luck!